If you've ever typed the same command into a Linux prompt 5, 10, 15 times, then you've encountered the same problem that Linux shell scripting solves. Maybe you create the same folder for every project. Maybe you rename files in batches. Maybe you run the same setup commands every time you open a new machine or server. At some point, repeating work stops making sense, and you want Linux to do it for you. In this video, I'm going to show you what a shell script is, why it matters, and how you can write one for yourself and use it. We're going to start with the basics. Build up to an if, and then a while statement, and then finish with a real demo using a tarball to back up real log files. So as a bonus, I'm going to show you how you can hand off this script to a cron job so that it can be run naturally every day without you even touching it. By the end of this video, you should understand the basics of writing a shell script and feel comfortable creating your own. If you're ready, let's jump in. Before we write a script, we need one quick definition. The shell is the program that reads the commands you type into the terminal and executes them. On many Linux systems, that shell is bash, although there are others as well. So a shell script is just a plain text file that contains shell commands. Instead of typing those commands manually one at a time, you save them in a file and run the file. That means a shell script lets you automate terminal work. It's not magic. It's simply a repeatable list of commands with a little logic if you need it. So why should you care? First, automation. If a task is repetitive, there's a good chance you can script it. Second, consistency. If you type a long sequence of commands manually every time, you're more likely to make mistakes. A script helps you do the same task the same way every time. Third, speed. A script can turn a 2-minute setup process into a single command. Fourth, a shell script is deeply tied to Linux culture. Linux is built around tools that work well together, and shell scripts are often one of the simplest ways to connect those tools into a workflow. This is why shell scripting matters for system administrators, developers, DevOps, engineers, and even casual Linux users. Hey, enough talk. Let's build a simple script. I'm using Fedora for this demo, and I've logged into my local VM. I'm going to create a file called script.sh. We'll type vi script.sh and then hit enter. At the top, I'll use the letter I for insert mode. And I'm going to type the following sequence of characters: hashtag, exclamation, /bin, /bash. Now, this is called the shebang. I love that word. It tells the system which interpreter should run the script. In this case, we're using bash. So next, I want to add a few lines. We'll hit enter a couple of times, and we'll type echo, double quote, what is your name?
What is your name?
We'll hit enter, and then we'll type read name, hit enter, and then we'll type echo, double quotes, hello, comma, $name, close quotes. Now let's break that down for a moment. In this script, echo is going to print the text to the terminal. What is your name? The read name waits for the user to input and stores the value in a variable called name. Then echo hello $name prints that value of the variable back to the screen. So this script asks for a name and responds with a greeting. Even though this script is simple, it already shows the core idea of shell scripting, taking terminal commands, saving them in a file, and making the computer handle the flow. Let's go ahead and save our command. We'll type escape and then :WQ to quit. Now let's run this script. And there are really two possible ways that we could do this. First, we could pass the file directly to bash, and we could type bash script.sh and hit enter. Now it's going to ask me for my name. I'll type Michael and hit enter. And it says, hello, Michael. And this works. It works fine. So prefixing the script with bash allows it to run even if the file has not been made executable yet. The second way to make the script executable and run it like a program is by doing the following. We're going to change some permissions here. We're going to type chmod space plus x script.sh and then hit enter. Change mod plus xh adds execute permissions to the file. For example, if I type ls-la and then the name of the script, we'll see that we now have the executable added to the file. So we can also now execute the script simply by doing /script and hit enter. And again, it asks for my name. I'm going to say Mike this time. Hello, Mike. So the /script runs the script from the current directory. Hey, this is an important Linux concept. A script is just a file, and Linux permissions control whether you can execute it directly. Now this is cool, right? Let's improve the script slightly further by handling empty input. Let's go back into the script.sh and add a bit of branching logic with basic if statement. We'll type vi script.sh and hit enter. Now, we have here echo what is your name and then read name. So let's add the following logic. Just after the name, read name, I'm going to type I to go to insert mode. I'm going to hit enter, and I'm going to type if square bracket space dash in double quote $name square bracket semicolon, then hit enter, space over a little bit, type echo, and actually I can just reuse what's here, and then I'll hit enter. Back to the beginning of the line, type else, hit enter, space over, we'll type echo, double quotes, you did not enter a name, double quote. And then we'll finish this off with fi. Now the condition dash in $name checks whether the string is not empty. If the user entered something, the script prints a greeting. Now, otherwise, it prints a different message. So let's go ahead and test it out. We're going to hit escape on the keyboard, WQ to write and quit. So all we're going to do is just type .script and hit enter. What is your name? I'm going to leave it blank. And it says you did not enter a name. So this is where scripting starts becoming powerful. Once you can use variables, input, and basic conditions, you can create scripts that respond to real situations instead of just printing fixed commands. Another useful building block is the while loop. A while loop keeps running as long as the condition is true. So let's open our script.sh one more time. We'll type vi script sh, hit enter, and let's take out some of this logic here. I'm going to just backspace through some of this. And I'm going to type the following command. I'm going to type count equals 1. I'll hit enter. Then I'll type while square bracket double quote count close quote dash LE space 5 square bracket semicolon, then the keyword do, hit enter. We'll space over a little bit, type echo double quote count colon $count double quotes. We'll hit enter. Then we'll type the following: count equals $, parenthesis, parenthesis, count plus 1, close parenthesis, close parenthesis. At the bottom, we'll backspace over and we'll type done. So here the script starts with count equals 1. Then the while loop checks whether count is less than or equal to 5. That's what LE means, less than or equal. If it is, the script prints the current value and increases the counter by 1. Once the condition is no longer true, the loop stops. So let's go ahead and execute this script. We'll type escape, WQ to write and quit. We'll type the ./script and hit enter. It's going to ask me for what my name is because we left that part in, and then we'll hit enter. So we have an error here at line 8. Let's go ahead and take a look at line 8 and see what happened. And the issue is we need a space here before the bracket and before the end of the bracket. Let's go ahead and escape WQ to write and quit, and we'll retest our script. Enter my name again. Now, as you can see, the loop counts upward automatically. 1, 2, 3, 4, and 5. What you saw here matters because loops let you automatically repeat the actions inside of the script itself. So instead of writing the same command again and again and again, you can tell Bash to keep going until some particular condition changes. And this is powerful for scripting. At this point, you might be thinking, this is interesting, but what would I use it for? Well, here are a few examples. You can write a script to create a standard project folder structure. You can write a script to back up files to another directory. You can write a script to check whether a file exists before running a command. You could write a script to install packages and set up development environments on a new Linux machine. You could combine commands like find, grep, copy, move, tar, and many others into a single repeatable workflow. Now, this is one of the many reasons why Linux becomes so efficient once you get comfortable in the terminal. You stop thinking only in terms of single commands and you start building repeatable systems. Let's end with a more practical example. Imagine you have a real service on your system that is already generating logs. Over time, logs can be an issue, and so you need to be thinking about collecting and archiving and compressing these logs. We typically do this kind of thing because who knows when you might need to review system logs later for intrusion history or tracing a hidden bug in the system. On this Fedora machine, I've already cleared the screen, and we have VMware service logs under var/logs, and we're going to compress them with the tar command. So if we go ahead and type ls space -la space /var/log and hit enter, we can see the various log entries in the system. Now, for this demo, we're not going to make fake files just to prove that tar works. We're going to target real existing log files because that is much closer to how shell scripts get used in practice. And one important detail here is that these files are owned by root, which means a normal user cannot read them directly. That is normal, of course, for many system and service logs on Linux. And it gives us a chance to show a very realistic admin workflow. So here's what we want to do. We're going to type vi compress -vmware -logs.sh and hit enter. We'll go ahead and go in insert mode by typing the letter I. And let's type the shebang, the hashtag !bin/bash. And we'll hit enter. Next, I'm going to hit enter again, and I'm going to type backup _directory equals double quotes $home /log backups, close double quote, Next line, I'm going to type timestamp equals $, parenthesis, date plus percent y dash percent m, it's a lowercase m, dash percent d underscore percent capital H dash percent capital M dash percent capital S, and then close parenthesis. We'll hit enter, and then we'll type archive underscore file is going to equal the $backup directory slash VMware slash logs dash $timestamp .tar.gz, and then we'll close the double quote. And we forgot to put a double quote here at the beginning of the archive file. Let's go ahead and add that now. Okay, with that done, we'll go ahead and hit enter at the end of the line. And next we're going to type log files underscore files equals parenthesis, and I'm going to hit enter and put a close parenthesis. And inside of this, I'm just going to tab over one. Actually, I'm just going to space over a couple times, and I'll type var log slash VMware dash network dot log. I'll hit enter, type the same thing, var log VMware dash VG auth svc dot log dot 0. I'll hit enter, slash var slash log slash VMware dash vmsvc dash root dot log. I'll hit enter, var log VMware dash VM tools d dash root dot log. Now, of course, some of you might be wondering, hey, Mike, why don't you just create a variable for some of those repeated terms there? And I could, but for clarity of sake, what we're doing right now, we're typing it out so everyone can see. Okay, then I'm going to type the following text, found underscore files equals parenthesis. I'll hit enter, make directory dash p double quote $, backup directory double quote. I'll hit enter. Then I'm going to say for file in double quote $, curly bracket log underscore files bracket the @ symbol, close bracket, close curly brace, double quote, colon, space do, and hit enter. And then we'll type if space bracket space dash f space double quote $ file double quote space close bracket semicolon then, and then I'm going to type found underscore files plus equals parenthesis double quote $ file close double quote close parenthesis, hit enter. I'm going to type fi, hit enter, backspace over, and type done. Then I'm going to do another if statement. If square bracket space double quote $ curly bracket hashtag found underscore files bracket the @ symbol close bracket curly brace, double quote, space, dash GT, which is greater than, and the number 0, space, close square bracket, semicolon. We'll hit enter, and then down here I'm going to type then, and hit enter again. And we're going to use sudo because we're on a directory owned by root. I'm going to type tar space dash czf space dash slash. Let's hit enter. And we'll type double quote $, found underscore files, bracket, @ symbol, bracket, curly brace, double quote, space, slash again, and we're going to say greater than, symbol, double quote, $, archive underscore file, close double quote. We'll hit enter, and then we're going to type echo space double quote backup created at $ archive underscore file, close double quote. And then below this, I'm going to come back here and I'm going to type else, hit enter, echo, double quote, VMware log files were not found, dot, double quote, hit enter, and then down here I'll type FI, and I think that's it. All right, let's hit escape, :W to write our changes. Okay, so that was a lot, right? But let's walk through what this does. First, it defines a backup directory in the user's home folder. Next, it creates a timestamp, so every archive gets a unique name, and then it builds the final archive file name. After that, the make directory -p makes sure that the backup directory exists. Then the for loop goes through a short list of VMware log files and keeps only the ones that actually exist. After that, the if statement checks whether the list of found files has anything in it. And if it does, sudo tar reads the root-owned log files and compresses them into one archive. Notice the dash after tar-czf. That tells tar to send the archive to standard output. Then we have the greater than operator, which writes the archive into a file in my home directory. Now, that detail matters because sudo gives tar permission to read the log files, but the final archive is still written as my normal user. If none of those log files are there, the script prints an error message instead of failing silently. Okay, let's go ahead and execute this code. Let's hit the escape key on the keyboard, then type :WQ to write and quit. And for simplicity's sake, let's go ahead and just type bash compress VMware logs.sh and hit enter. Go ahead and enter your password. And as you can see, it outputs some details to the screen, and it's complete. Let's type ls space -la log -backups and hit enter. And we can see our compressed file. So this is a very practical Linux script because it combines variables, a command you would use manually, and an if statement that makes the script safer. And if your environment is different, the same idea works, whether it be Tomcat, Apache, a file server, or any other service writing logs under var log. You would just change the log paths to match the real service on that system. Now, let's take the same script and connect it to Cron. Cron is the Linux job scheduler. It lets you run commands or scripts automatically at specific times. The idea here is instead of remembering to back up the logs yourself, you schedule the script to run every night. Let's go ahead and create a Cron tab now, and we're going to need a couple of things before we do. First, we're going to need to know the location of our script. And as we can see here, pwd gives us our folder location, and ls gives us the location of our script. So we'll type cron tab -e, and before we do, I'm going to copy the file, hit enter, type I for insert mode, we'll type 0 space 2 space asterisk, 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 all separated by spaces, then slash home, your username, slash the script. Basically, this means that the script will run every day at 2 a.m. Go ahead and click escape, W and Q to quit. Now, there's also one other thing we have to do here, and that's to ensure the script is executable for Cron tab, because, well, we didn't do that earlier. So we'll go ahead and type change mod space +X home Michael and, of course, our script. This is where shell scripting becomes even more powerful. You're not just writing commands into a file anymore. You're building repeatable jobs that Linux can execute for you automatically. There are a few more things that beginners should keep in mind. First, start small. Your first useful script does not need to be overly complicated. Second, test carefully. A script can save time, but it can also repeat mistakes very quickly if you're not careful. Third, learn a few core ideas as well. Variables, input, conditions, loops, and permissions. Those basics go a long way. And fourth, remember that shell scripting is often about glue. It's not always about writing huge programs. Often, it's about connecting small Linux tools into one useful process. So, to recap, the shell is the command interpreter behind your terminal. A shell script is a text file containing commands. Scripts matter because they automate repetitive tasks and improve consistency and save time. And on Linux, shell scripting is one of the most practical skills you can learn because it fits naturally into the way the system works. If this video helped, open your terminal, create a file called script.sh and write your first script. And maybe if you made it this far, drop a comment below and tell me what your first shell script should do. Or if you want to have a little fun with it, comment, I came for the Linux scripting and stayed for the tarball. I know that's cheesy. If this video was useful, click like so I know to make more Linux content like this, and subscribe if you want more practical tutorials on Linux scripting and system administration. Blessings, everyone.